Hello viewers, welcome to my YouTube channel. This is sirkoech, and today I'm going to talk about Demoivres theorem. And before this theorem, I want us to recall back complex number. In complex number, I believe in our previous chapter we know how to represent complex number in polar and in rectangular form. So in polar, say if we have, let's say x, z is equal to x plus yi. So this one is rectangular representation of a complex number. We also note that a complex number, it has a real number part and imaginary number part. So complex number has a real part which is usually lie on x-axis, and imaginary part which usually lies on y-axis. We can also say that complex number is denoted by this, such that if z is equal to x plus I plus yi, so we can represent this one on Argand diagram. And the Argand diagram, now you can say that we draw a Cartesian plane. So on x-axis we say that this is real number, and on the y-axis we say we have the imaginary number. So you can be given, let's say z is equal to maybe 3 plus 3i. So on 3 plus 3i, so the imaginary part is this one on y-axis, and you have the real part. So complex number, not this one, not complex number, help us to get the square root, the square root of a negative number, i.e. the square root of negative 16. The square root of negative 16. So the square root of negative 16, you can say it is root 16 multiplied by I. So I is equal to negative 1. I is equal to negative 1. Therefore, I is the imaginary part. So the square root of negative 16, the square root of 4 of 16 is plus or minus 4. Then multiply by I, and I is negative 1. So we have the square root of negative is equal to plus or minus 4 I. So you can say plus or minus 4i is the same as 4i or negative 4 square root of negative 16. So complex number help us to get the square root of a negative number. So in Argand diagram now, if you have this is the imaginary part on the y-axis, then you have the real number part on x-axis. So given that z is equal to 3 plus 3i, we can represent this one now on Argand diagram, where we have on x-axis we have 3. So let me say 2, 1, 2, 3. Then we have 1, 2, 3. So 1, 2, 3, negative, 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 1, 2, 3. So I'm going to show you how it is represented on Argand diagram. So it is 3 on x-axis, so 3, then on the y-axis it's 3. So I'm going to draw a line. So this is the representation of complex number on Argand diagram. So we have, remember, this one is rectangular representation. So we have angle here, this theta, and we say polar representation of complex number is z is equal to, let me say z is equal to r theta plus I sin theta. So you have to note this one, r z is equal to r cos theta plus I sin theta. So this one now is polar representation of complex number, of which I'm going to show you how you can get r and how you can get theta. So for this, z is equal to 3 plus 3i. So to get r is equal to 3 squared plus 3 squared and the square root. So we say r is equal to the root of 18. 18 can be obtained by saying that r is equal to root 9 multiplied by 2. So root 9 multiplied by 2. And root 9 is 3. So it's 3, then root 2. So root 9 by root 2 is root 18. Now this is r. So remember, if you want to find angle now, or theta, angle theta is equal to the tan inverse. Tan is equal to opposite of adjacent. And our tan theta here, the opposite over the adjacent. So we have the opposite, which is 3. So from here to here is 3. From here to here is 3. Then from also here to here is 3. So tan theta is equal to opposite, which is 3 over 3. So the tan inverse of 1, which is 45 degrees. So the angle is 45 degrees. So now I'm going to show you how we can use Demoivres theorem to explain the concept of a complex number. Where is that duster? So I'm going to show you a simple step to tackle Demoivres theorem. So in Demoivres theorem we say that if I have a plus bi, this is z, is equal to a plus bi one now, this one is equal to, this one is a rectangular representation, so it is either r is equal to cos theta plus I sin theta, where A, B, the member of complex, A comma B is the member of complex number. So the Demoivres theory states that if the modular argument z is equal to r comma theta, z is equal to r comma theta, then the theory says, then the theorem says that if I have z1 multiplied by z2 is the same as r1 multiplied by r2, then multiplied by cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. Also, if z1 divide z2, so if z1 divides z2, then r1 divide r2 multiplied by cos theta 1 subtract theta 2, now plus I sin theta 1 minus theta 2. You should also note that if I have z1 multiplied by z2 is equal to r1 multiplied by r2 multiplied by cos theta 1 plus theta 2 plus I sin theta plus theta. And you know how you can obtain the theta. Theta, we apply the rules of Sokotoa, but when we want to find the theta, it's tan inverse of tan. We use tan. Tan is equal to opposite of adjacent, and then you find the angle, and r is here. So for example here, r is 3 to 2. R is equal to 3 sub 2. So you can apply and get the angle as 45 degrees as you get that. So you can represent that one on a complex number in that form. So also, if I have the theorem, if I have z, I want to find the z raised to power of n, the same as I multiplied by cos theta, then plus I sin theta, then everything I raise to the power of n, which is the same as z of n is equal to r n cos theta plus I sin theta. So this is the concept of Demoivres theorem. So if you apply this concept now, you will find it easy to tackle question on complex number. So I urge you, please subscribe to my YouTube channel as sirkoech. Thank you.